the previously published vulnerability within Kubernetes, which leads to MITM. So we can discuss later on if you see it as a real CVE or not, but the community sees it at that. But yeah, it's quite a funny stuff because it's complicated to fix in tree and so on, and we will discuss all of this later on, I think. So I will show you exactly what the issue is, the main issue which was discovered, and how one can fix it. So if you have some Kubernetes clusters running there and you are affected, you can fix it quite easily, I think. So with workarounds or some other options. So first we will start with Kubernetes Service. What does it mean and how it looks like? So Kubernetes services are mainly used to load balance traffic to different pods running behind those services. So if you have a Kubernetes cluster, you deploy your app, your pods or your containers within your pods as a virtual abstraction, they may come and go. So especially if you have some horizontal auto scaling or such things enabled, you cannot count on addresses to remain the same. That's why there's a object or a definition of a service within Kubernetes. So a service will remain the same, and when you run different microservices, you can change them using services. That's the way to go. And services targets different pods behind using selectors. So you need some tags for your pods, and then you can add this to a service definition, and here you go, where your traffic is redirected to your pods behind. And usually if you create services by default, you use cluster IP as a type. We will get on types later in the next slides. And a service is, as I said before, it's a virtual object or virtual construct. So it's used within IP table rules, and it forces or it leads to traffic redirection. So let's look into how it works by looking into the illustration from the docs. You can see here we have a client, and this client tries to access some app running in your Kubernetes cluster, and this app can be scaled, for example, as here, to 3 pods. And kubeproxy, this one is the main part if you run kubeproxy in your cluster and you run it with IP tables, which is the default mode. Previously, it was running with user space. You have an option to run it with IPVS, and when you run it in former days with user space, it actually behaved like a proxy. Now the name is somehow confusing or misleading, because it's not a proxy anymore. It simply configures IP tables rules, a lot of them, to redirect your traffic if you run it with IP tables. And pods here illustrated have one label, like app, my app, and this one is then set within the service definition, and the traffic got redirected to the pod opened here. So let's see some fancy YAML engineering, which is the way to go if you define your stuff in Kubernetes. So we have here kind service, and we need to set a name, as it's mandatory for objects in Kubernetes. Why? Because it will be resolved internally. So you have to provide a name which is okay for setting within a DNS subdomain or something, right? Because so as a DNS record, because it will resolve internally to my service, for example, and then in the namespace default, because nothing here is set, that's a service object, and you have your cluster local as the domain. So you can do some DNS resolution as usually within your Kubernetes cluster. Here you have your selector for your service, for your pods, where you would like to route your traffic and here you have some port mapping. So we do not need to have the same port open, because we can have some multiple containers running, and they all will have the same port. And our service may have another port, and different service types have different port mappings, for example. We'll look on it later. And the last one is a cluster IP. So I think, if I remember correctly, you don't even have to set it, because cluster IP is the default type. But you can look in the definition in the docs. So when you look into the docs, you may assume, okay, I see there are mainly 3 types of services. Well, it's a bit confusing, because actually there are 4 types. But if you really look into the services, there are only 3 types, like in a hierarchy. Like you have the cluster IP, the lowest one. Then you can create a node port. A node port simply opens a port on a 30K range on your nodes, where you can receive traffic externally, for example. And you can set a load balancer if you use Kubernetes providers like AWS, Google, or Azure. It will create an external load balancer for you. And this load balancer will redirect traffic to some open ports on your node. So it's acting like a hierarchy of what you can set. But there's even one more type, like a headless service, where you find none. This is mainly used for service discovery when you run stateful applications, which is quite hard to run correctly or without any issues on Kubernetes. But within this talk, we will look into external IPs. This one is not a type of a service, but somehow an extension, an additional option you can set on a service type to define external IPs, as the name suggests. If we look into the docs again, they have quite good explanation about this section about external IPs. To summarize it with my own words and to try not to confuse you, well, we have some IPs, right, which are external. So like we have an IP 1, 2, 3, 4 we control. And it may happen that we can somehow route packages or packets to this IP to our Kubernetes cluster. And our Kubernetes cluster may run somewhere within private subnets and so on. And Kubernetes does not care about those external IP addresses. So we need somehow to tell Kubernetes, hey there, we have some external IP addresses. If you receive traffic for those IP addresses, so as a destination, please route these packets to a service where we specify these IP addresses. So quite simple, right? And well, where do we need such behavior or such constructs or such complex setups? One may suggest. Yeah, well, if you use a load balancer type, you will get somehow these external IP settings already set. We will look into it in a few seconds. Or you have some bare metal setups or setups where you do not have any load balancer like F5, Kemp, Citrix, and so on. And you need to provide some external IPs where you can route the traffic and it lands in Kubernetes. So maybe some of you guys ever have experience with or ever touched MetalLB. MetalLB is one solution you can use if you have some bare metal setups. So MetalLB can provide you IP failover. It's one of the modes. If I remember, if you are using ARP, so it will control. It will delegate one IP address to a node or set it that this node should receive traffic for this IP address. And if this node crashes, it will redelegate, for example, this IP address to another free node which is alive. So it does somehow an IP failover, for example. And maybe you have some complex infrastructure set up in big enterprises, for example, where you need such settings and so on. And more on this. If you have some idea, we can discuss it later. I simply dropped a few lines here, what was in my mind, on my mind. Yeah, and let's go to a demo. So within this demo, I have here a Kubernetes cluster set up locally with 2 nodes. I have a master node and a worker node, simply running with Vagrant in VirtualBox. So, and as you can see, I have some pods already running there, and I have some services defined. So, and I've already a workload running, simple Nginx returning me the Nginx welcome page, nothing more. And we would like to access this Nginx. So for this, to be able to do that, we can deploy an ingress controller, for example, if we are dealing with web applications, or if we try to, or if we like to present anything within the browser and so on. And if you see here, ingress Nginx is already deployed with a service, and this one is a node port service type. So if we look onto the node IP addresses, they are listed as internal IP addresses. So if I take this one, so let me take this one, and I go, so to exit this one, and they go here, and I paste it here. Well, connection is refused. Why? I think the port is simply closed, right? Because there's nothing about port 80. So this one is closed. But there's some port mapping because it's node port type. So if we take this one and try to access Nginx on this port, you see, okay, welcome to Nginx. It works as expected. Everything okay, right? Now, what if I would like to simply send traffic on port 80 to all of my nodes? Because I need I would like to access them over DNS and so on, or what can I do? One option is, for example, as I told before, where you may need this, is to add this external IPs section. So let's do this. We go to the service definition, external IPs, and we simply set the node IP address. So I think it was 11, right? So, and now, if we go and try to access our app, you see it works. What's happening behind? One of fancy stuff kubeproxy is doing, it simply opened some ports on this IP address. So it's listening now for the nodes to be able to accept this traffic. So it's not blocked anymore, right? So yeah, cool stuff. We can add some DNS, for example. We can access our app over DNS. We can even request certificates and work internally within our cluster, within our development environment, for example. It's quite handy, right? So I think you got the point. And then someone discovered this after a couple of years that, well, guys, this seems to be an vulnerability, right? Why is it a vulnerability? Well, as we've discussed before, you can set some external IP addresses to serve your, or to for Kubernetes to accept this traffic, right? And what happens if we set some completely random IP address or some completely external IP address, like for a famous website you may be aware of, like WhizUs, for example, WhizUs.com. What will happen within our Kubernetes cluster? Yes, kubeproxy will add some fancy rules to IP tables and route this traffic, because the destination is WhizUs IP address, route to the service containing this section. So, well, impact is you can do MITM, because if I set a service to get those packages, which should normally go to an external source, it will intercept it. Yeah. how can we fix such things, or how we can fix exactly this one? Well, within Kubernetes, you have the concept of admission control. You can use it for different things. One of is, for example, namespace auto creation. It may happen that you don't like always to create namespaces, but if you check in code and there's some namespace defined and it's accepted to master, you would like to auto create such a namespace because it was already reviewed, but it's still not there. You can enable such an admission controller within Kubernetes. So it's like enabling or disabling features or something like that to explain. Yeah, and there's already a fix provided by guys from the Kubernetes Special Interest Group for Security. So it's exactly that. It's an admission controller. I mean, if you use OPA or Coverno or some other admission control frameworks or policy frameworks, you can use them to define your own rules. You can take this one and deploy it within your cluster and add some exceptions. Maybe you would like I did, permit internal IP addresses of the nodes, but nothing from externally, so for example. Or there seems to be some CNIs like Cilium, one of the greatest one, I think. If you run Cilium with eBPF, so you don't need kubeproxy anymore, and you don't need to configure IP tables and so on, you are not affected anymore. How it is fixed behind, or if they even applied a patch or anything, one should look into their GitHub or into the implementation, because it's quite hard to understand what they are doing there. It's quite complicated stuff, but it's a way to go. Linux is developing then in the future, I think. So yeah, let's look into exactly that. So first, let me start a netshoot container. Netshoot container is a collection of different networking troubleshooting tools so you can use. So if you have any networking issues, I suggest you to try it out. It's quite nice. So let's look into this famous website I mentioned before. I'm visiting every day. We have here an IP address set or returned from DNS, right? And if we curl the website, let's see what's returned. Okay, we get some redirect returned. If we follow redirects, we see we get some fancy HTML, tons of it, so displaying the website. Seems to be okay. That's what we expect here. Okay, now we will deploy some pod, an Nginx again, with a service where we set this IP address as external. But before I'm doing that, let me show you how we can investigate, or can we look into IP tables, what's going on there. So if we look for the IP address in any IP tables rules, we will not see anything for this, because nothing is there till now, right? If we look into IP tables for all rules, you see there are a lot of them. So debugging IP tables is a hell of a work. Yeah, let's set or let's run this MITM pod. So I'm deploying it, and if we look again into what's running there, you see this pod is running, and there's a service for it. And this service is basically one cluster IP, and it has this external IP section set. So, okay, what's happening in IP tables? Just look into it. Well, thank you, kubeproxy. You added some rules for that. It works like it was designed to, right? So, but if we go to our test pod and we curl for this famous website, well, there's some different response right now. Unfortunately, WhizUs is not a steakhouse yet, maybe in the future. this is not what we expect here, because traffic seems to be intercepted and it was redirected to our pod running in Kubernetes, right? So, well, quite a fancy issue. So when you have, or when there's a malicious actor who is able to somehow update or create services within your clusters, and you have not a patched version, or you are using a provider who is still patching it, you may be affected, and it can result that, yeah, your traffic got intercepted, unless you use some more advanced features like service meshes with MTLS and so on. Yeah, can lead to your secrets being leaked, right? Well, let's first remove this one. So it's removed now and nothing is there. So should be gone. Okay. So if we look into IP tables again, it's deleted. Everything seems to be okay. Now we would like to try this admission control solution. So from the Kubernetes guys, I changed it a bit because you need some external dependencies like cert manager and so on. I just generated my certificates using CF Cloud Flare SSL tool. It's quite handy. And how do they fix that? So they define a validating webhook. So it's a validation which happens after a mutating webhook. So there are only two kinds of webhooks available, mutating and validating. Because if you mutate or you change an object and you would store it, well, you need some validation there, right? And it tells Kube API server that if it receives an object, a service object, for a creation or update, so if there's an object updated or created, it should first throw it to this path on the webhook. We need to deploy a webhook. I will show you what it looks like. It's quite simple. Then the webhook will validate it and return an OK if everything is OK, and throw an exception. So return an exception if there's something not OK with the object. So if we look into the webhook is a simple deployment where you can run Java, Go, whatever you like within your container, and listening on this path defined in the validation webhook. And as you can see here, they suggest, yeah, you can add some CIDR ranges to a whitelist for what you allow, like internal IP addresses or so on. Everything else will be blocked. So now try it out and simply deploy this one. So if I deploy it, if we look, if it's already, oh, I think it's too much. Yeah, the formatting is a bit bad. So I hope you can see it. Now you can see here the webhook is actually deployed. And yeah, it has a service too. So it's accessible right now within the Kubernetes cluster. So what happens if we try to launch our MITM pod again? So you see, OK, now it's not allowed because it's blocked by admission control of Kubernetes. So admission webhook simply blocks because we have some IP defined there. If we try to remove it, for example, just comment it out. And if we create it, everything is fine because there's no external IP section defined anymore. So this is one solution. So if you need to fix it, this is maybe the way to go, or use OPA, Kyverno, or other policy frameworks. But there's another option if you have Cilium running, for example. So let me show you. I will just show what it looks like on Cilium. So if we run on Cilium, I have one master worker node here. We have no kube proxy anymore because Cilium runs in eBPF mode on this one single node cluster. What happens if we try out with our Netshoot container. Start one here. And we call for this famous website. So you see tons of HTML code returned. Everything seems to be fine. So let's go and simply deploy our MITM pod. So I have to first remove the external IPs, sorry. So if we look again into it, we see external IP section is defined here. So it was just deployed without any issues. But how it looks like, will the traffic be intercepted within Cilium or not? So if we try it again, you see it's still responding with the real content. So traffic gets not intercepted and the destination seems to be what we expect it to be. Yeah, so if you are running Cilium or maybe other CNIs, you will not be affected with this. And yeah, thank you a lot. If you have any questions, just ask them or let's discuss later on. I have some references within the presentation I will upload later, so you can deep dive into IP tables, magic with kubeproxy and so on if you like. You can look in Cilium and so on, or you can try out the webhook. For sure, try to figure out if you are affected or not and patch this one if you like to be still secure. And that's it. Thank you. I'm done. So.
Thank you very much, Jimmy. That was cool.
Great. It was actually fun to watch with all the magic going on in the terminal. Really cool. Thanks for doing everything live. It's really appreciated. There are some conversations in the chat, but I think it's not yet a question. There was one question, if there is a recording. Yes, we are recording this. So we did not record the breakout part, but we started another recording for the second talk. So also the talk of Dimi is recorded and we will put it on the YouTube channel of our CNC meetup. Yes, there are some nice comments on your talk. You already see it, Dimi. That's great. So if there are any questions, please feel free to open up the mic or type in the questions in here. Yes, we will share the link to the YouTube channel also here in the chat. And I can take care of this. Juliana, do you have any question on Dimi's talk or anyone in the audience? Any questions?
Well, regarding the question that we have in the chat now, no certificate for participation in the webinar.
Yeah, it's an open meetup, so we do this monthly. You can just join this meetup, but we are not. It's not an official hosted meetup. It's officially hosted on meetup.com, but and yeah, sure, you can join every month, and we will also post the link again to our meetup group. Just sign up on meetup.com and join us. Then I think we can move on to the next part, actually to the last part of our agenda here, which will be the raffle of our packages.
I'll share my screen again. Thanks again, Jimmy. Thanks again, Oded, for the great presentations. So we have now 19 people, of course, including myself, Jürgen, Jimmy, and Oded here. So if one of those are, if we get one of those numbers in the raffle, then we will try another one. Cool. So basically, I got everyone and assigned a number to each one, and I'll use a random number generator on Google. And I have here the minimum 1, max 19, and I'll run it 4 times. So let's go. First one, 17. That's Raul. Raul, in Zoom, there is in the chat, there is a feature where you can send a message just for myself. So you can go in the chat and select 2 and put Giuliano and send a message for me. If you could share your address, I'll post one of the kits that we get. And as soon as we get the, sorry, let me get hit here. As soon as we get the shirts from Rookout, we will also send to you. So the second number, 14, and that's Mario. Mario, maybe I can, well, I can also send to you, but if you are going to the office or something like that, well, we can discuss this.
Yeah.
Cool. Next one. Oh, 30. And that's Hauko.
Yeah, cool. Thanks.
Great. And last one, 8. And that's Ihan or Ian. I'm not sure how to pronounce.
In English is Ihan. Ihan. You can.
Ihan. Okay. Awesome. So congrats for the winners. Hauko and Mario, I think you guys, if you would like, you can send me on Slack later on.
Yeah, sounds good.
Yeah, cool. And
I messaged the other 2 winners in our Slack or in our Zoom chat here.
Cool.
So if you're still with us here and listening, just please reach out to us, write back to us in the Zoom chat, so we have your address and we can send you the swag, or just to send a message to Giuliano or myself. That should be fine.
Yeah, well, you can also reach out via Discord if you are part of the. In Discord, you can also reach out just to me. You don't need to send the message on the group.
Yes, I will also share my Twitter handle, so you can also reach out here, because if once we're closing the session here, it's not possible to reach out on Zoom.
Once again, I would like to thank Rookout for the support. And let me just share with everyone here. I have it here, one of the kits that we will send. So basically it's the kit that KubeCon, the kit from KubeCon 2020 Europe. And inside we have a mask that unfortunately we cannot use anymore here, at least in Linz, because it's not the one from the pattern. We have well, it is a patch, but we are using I'm using as a coffee table beer. What's the name, Jürgen? Like when you put the cup on top of that. Well, that's it.
Ah, okay.
2 stickers and the shirt from the last Europe KubeCon. And then we'll be adding to that, well, we got 3 shirts from Rookout, and we will add to maybe one of them or 2 of them, 3 of them, the shirt from Rookout as well. But this kit we already have. The shirts are on the way, so maybe we will handle in a different way. Cool. And last but not least, we would like to announce that we already had a date for the next event. That will be February 23rd. So that may change a little bit, but end of February last week, as we are doing usually every month in the last Tuesday of the month. And we are already discussing with some speakers. And again, if you are working with something and if you are related to cloud native and you would like to share that with the community, everyone is welcome to share, and we would love to have anyone sharing their experiences and things that they are working on. Cool. Regarding the question that we got in the chat, currently there is this Linux Foundation mentorship program that Jürgen had mentioned at the beginning. I'll share the link in the chat. You can take a look. That's a paid program that you can use to start in the open source community. So that's a nice. There you go. Cool. I didn't get the address for the
unfortunately,
2 guys.
I could not. Yes, for I could reach out to Ayan. We got his address for Rahul. I have not. Rahul, he has not yet responded. So I sent him again the link to our meetup group. Please reach out to us. You can also find us as the organizers of the meetup group, and then we can send you. Oh, are you still online here, Rahul?
Yes. Yeah. Okay.
Please reach out to us with your address, and we are happy to send you this Whitebox.
Okay, fine.
Cool.
Thank you.
Thanks everyone again for joining. Anything else, Jürgen, that you would like to say?
No, thanks everyone. It was great to have another meetup, the first meetup of 2021. Looking forward to see you all in the next meetup in February. Thanks again to the speakers. You really make these meetups happening. So thanks a lot. Thanks also to the sponsor. And if you have any feedback, how you like these breakout sessions within the breakout rooms, how you like the talks, feel free to reach out to us on meetup.com, in our Discord, on Twitter, on Slack if you have our Slack. Really great to see this community growing, and looking forward to see you soon in the next meetup.
Thanks everyone.
Have a great evening.
Take care.
Thanks.
Bye.
Bye-bye.
Good to see you. Thank you. Bye.